Hello, student. Uh, Today's topic is Dalton's atomic theory. So, Dalton was associated with explaining how a structure of atom could be. It was the initial days when nobody knew how the atom is. So, he explained his observations that atom should be in a way that he explained in Dalton's atomic theory. So, firstly, he told any material, let's say this pen is made up of matter and it has small tiny particles, and those particles are called as atoms. And then, secondly, he told that each element has a special type of atom, and all the atoms in an element, let's say oxygen, all elemental oxygen atoms are same. Hydrogen element will have all atoms same. So that was the explanation he gave in Dalton's atomic theory. And thirdly, he told that they can never be divided in smaller things. But later on we found out there were limitations. What he explained was, he told that we cannot divide, but later we found out that atom has consists of three things. Let's say atom has neutron and proton at the center, and this is called as nucleus. And there are circular orbits in which electrons are revolving continuously. So basic structure of atom is like this. So this was okay. So this was how it was uh, concluded that atom should be like this. But Dalton's atomic theory failed in certain aspects, which were later finally we concluded that neutron, proton, and electron are subatomic particles. What Dalton told was atom can never be divided. What we found out was atom can be divided further. Small particles are there inside atom which are called electrons, protons, and neutrons. Secondly, Dalton told कि all atoms of an element are same, but we found out there are isotopes. Let's say hydrogen atom. There are three types of atoms in hydrogen. One is H, the other atom of hydrogen is D, and third atom is T. Hydrogen atom has atomic number 1 and mass number 1. Deuterium has atomic number 1 and mass number 2, and tritium has atomic number 1 and mass number 3. So all these atoms are of hydrogen, but they are different. So this was a limitation, you can call this, or drawback. So these are things which were explained in Dalton's atomic theory, and later we found out that these are not as the reality is. All right. So these are the things we understood in this page. Heisenberg uncertainty principle. You must have heard about it. And what does it talk about? It says that the speed of electron and the position of electron we cannot determine accurately at the same time. If you are going to calculate the speed or momentum of an electron inside atom, then you have uncertainty in the position. If you are going to calculate momentum, you have uncertainty in position. So what is uncertainty about? Uncertainty is the percentage of doubt you have whether it is correct or not. That is called uncertainty. Uncertainty is nothing but the doubt fraction you have in any value. All right. So uncertainty is the percentage you have doubt. So what he told is we cannot determine anything perfectly. What we have is we can determine up to a certain extent, and we have certain doubt. That means anything or everything is determined in probability. So probability is something we have to consider. According to his theory, what he gave in his theory was that if we multiply uncertainty in position with uncertainty in momentum, that should be equal to or greater than h by 4 pi. All right. So delta x is uncertainty in position and delta p is uncertainty in momentum. So if we multiply both these, then they have to be greater than equal to h by 4 pi. If we put the value of momentum is m into delta v, because we can't have uncertainty in mass, right? Mass is constant value. If you have uncertainty, you will have uncertainty in velocity only. So in place of uncertainty in momentum, we place m into delta v. So if you get m this side, you get this formula. Delta x into delta v must be greater than h by 4 pi m. And the mass m is the mass of electron. All right. Everything we are talking about here is about electron. It is not for all other particles. We are talking only about specific to electron. So uncertainty in position of electron inside atom, uncertainty in velocity of electron inside atom, that has to be greater than equal to h by 4 pi m. All right. So this is known as Heisenberg's uncertainty principle. For this, he was awarded a Nobel Prize. So you can imagine what level of discovery this was. This was another a breakthrough in the discovery of atomic structure. All right. And one more point I would like to add to this. These all things we are discussing, dual behavior of matter, de Broglie's and Heisenberg uncertainty principle. They gave very accurate values or significant data when applied to microscopic bodies. Microscopic means very small objects, but when they were applied to larger uh, particles, they do not give significant value. So they are very relevant to microscopic bodies, small particles. All right. So this is Heisenberg uncertainty principle for you, and this led to the next Erwin Schrödinger model, which we are going to study further.